And now we go on to our next talk. Our next speaker is Sarah Brown, who will be presenting opportunities for a more interdisciplinary approach to perceptions of fairness in machine learning. Welcome, Sarah.
So thank you. I'm Sarah Brown, and I'm going to be presenting on interdisciplinary approach to measuring perceptions of definitions and fairness in machine learning. And this is joint work with my co-authors at Brown University. One is moved back to Berlin and from CCAB Analytics. And why do we care about how people perceive about these things? And though the definitions are definitely imperfect, as the recent talk just shared, these algorithmic decision systems are a matter of public life. And so as a matter of our everyday life, outside of the world we study as researchers, it's important to understand how the public understands them, perceives them, what do they think about them. For making policy decisions, having broad understanding of what different people think of these definitions can help designers sort of engage in how their own identity intersects with what they think about them. And further, just psychologists study how people understand different things in life, and the nice structured modern context of these things could serve as a rich stimulus base for psychologists who have been studying these questions or similar questions otherwise. But in order to use these measurements, we have to actually be able to have good measurements. So making decisions or policy decisions or anything based on what people think about algorithmic systems relies on us knowing that the measurements of those perceptions are good, that they'll reproduce, that they're meaningful. And measuring people is very, very complex. So there's been a number of computer scientists, machine learning researchers who have started trying to measure perceptions of these algorithmic systems, whether the goal was the sort of purely descriptive approach to just sort of understand, or some have been said, well, if we could measure it, maybe we can optimize for that, which we're going to advise against, but we want to measure it. But unfortunately, people are really hard to measure, and often they're much harder to measure than the things that we typically validate. Oh, I made this new system, I'm going to check if it works. But if you're trying to make inferences about how people actually came to their complex decisions that they make in their lives, we need to kind of consider the wide variety of spurious causes that could be influenced. And fortunately for us, psychology researchers have spent decades grappling with these challenges. And so what our paper does is it talks about a few patterns we saw in some research that was recently done. And so what I'll do in the talk is I'll go over a few of the studies, very high level. They're very good papers. We do recommend to read them, but we're going to talk about some of the psychological phenomena that come up in these. We'll give a brief definition and an example of how it impacts the results that some of these studies found. And over the course of the talk, we'll build sort of a design checklist. So what things should you be doing to make sure that you don't fall into these same sort of measurement errors in trying to understand how people perceive and understand algorithms. The impact of algorithms, in particular in the context of fair machine learning, is what we've studied, but these ideas should generalize. So to go over the studies, the 4 that we'll be looking at, Saha et al. Measures, do people understand the definitions and the trade-offs between them? So they gave people sort of illustrations of the different definitions, and they asked them to apply the rules and saw which ones, could people apply the rules correctly. Harrison et al. And you et al. Examined trade-offs between definitions and specifically asked people to illustrate their preferences. Harrison et al. Focused on sort of pairwise comparisons, like here's one, here's the other, between fairness definitions. You et al. Revisited also some classic trade-offs in performance metrics. So like, do we want overall accuracy, or do we want lower false positive rates, or do we want lower false negative rates, or whatever? We're kind of trading off in that space. And Srivatava looked at how does the context of the algorithm being deployed influence people's preferences. So if it's a low stakes decision, like kind of delayed treatment versus like a high stakes decision where they're like gonna die from the diagnosis, does that change whether people choose, what people choose for their decision? And the first phenomenon that comes up is it's called measurement reliability. And what this means is that when we're measuring things in people, there are actually procedures for how to develop a reliable measurement. And one of these, there's a whole bunch of statistics you can use, and there's strategies and all these things. And one thing we found was in Saha et al., they calculate a score, Crohn's alpha, to check the reliability of the comprehension of how well their set of questions measures the people's comprehension. But they get low values. So they got values between 0.48 and 0.64. And the threshold for that is typically accepted at 0.7. So they didn't get sufficiently reliable metrics. And further, they removed some of the questions from the score calculation to get a higher score. So this brings into question, like, how reliable are those results? They found, for example, that people who understood them better were less trusting of them, but their measurement of comprehension is not quite reliable, so it's hard to interpret those results. So advice for that is that we need to validate the surveys separately from the confirmatory experiments. This is analogous to, we have separated training and test data and machine learning framework typically. We have to do the same thing if we're developing novel surveys, which for studying people's perceptions of algorithms is always going to be the case. These aren't things that psychologists have been studying for decades, so we don't have standard measurement tools for these. So we'll have to be kind of increasing the size of these studies and varying them more. The next phenomenon we saw is a framing effect, which is to say that the way we present the questions we ask people actually can influence what they respond, independent of their actual beliefs about the thing we want to ask them, just the framing of the question. And in this particular case, we'll look at loss aversion. So, and that says that people will avoid losses more strongly than they choose a positive outcome. So this sounds negative, I'm gonna not pick that one. I don't want that outcome, I'm gonna avoid that. Even if the other thing is equally positive, they'll choose to avoid the negative one. So in Harrison et al., they asked people whether they prefer whether they would prefer equal rates of mistakenly denied bail or equal accuracy across subjects, across the people the algorithms apply to. Mistakenly denied bail sounds negative. So people are gonna say, oh, that's a worse outcome for the people that are impacted by the algorithm, and they're gonna choose this. And that is in fact what Harrison et al. Found. It could be that people do prefer that, but we can't tell because the two questions weren't framed equally. They weren't framed in the same valence, one positive and one kind of negative or neutral, so we're not sure what they prefer. So we want to be sure that we give people choices. We frame them always with the same valence in a given question. There are other framing effects too. So it also is that people prefer things that are concrete. They know what it means, they're more likely to understand it. And we ask people abstract questions, that's going to affect their degree to which they would prefer to make that choice. So since accuracy is more abstract than mistakenly denied bail, that's going to again draw people towards, I know what that means, and I want to avoid that. I want to make sure that's equal accuracy. I'm not sure exactly what it means. And so that could further bias people's responses. So we also want to make sure that when we give people choices to make in a survey setting, that those choices are framed at the same level of abstraction. So for example, if we said mistakenly denied bail or correctly denied and correctly granted bail, or you could go to choosing both abstract. You can say accurate and equal false positive rates. Because they're equal, those are a fair comparison. Whereas when they're from different levels of abstraction, it becomes difficult for people. And that's one of those sort of confounding effects that may influence the results in your study. The next point is really more of a missed opportunity. Of these 4 studies, only one of them asked people why they chose the choice they made in great detail. And this is another opportunity to use these studies to really understand what's going on. And it can also help you kind of minimize and validate in the context of with so many spurious potential causes to help sort through and help to filter. And these would be particular, asking questions about why is particularly important if you're designing the study. If you're doing that sort of initial validation, making sure you're getting as much information so that you can go forward. with a reliable study that you can actually understand. And so our advice here is we want to ask why in addition to what. And though causal questions are hard, we can ask people to explain the choice they made, and they will tell you things. So this is an important choice to make. The next point is generalizability. We, of course, want, if we're measuring something, we are hoping that our research is going to apply to the real world. And generating generalizable results is really hard. Having laboratory kind of settings where we're doing experiments and asking people questions is going to make it hard. But there are things we could choose. For example, one of the studies, or a couple of the studies actually, they balance the size of the racial groups in the presentations that they give to people. So they make equal numbers of Black and white people, and then they ask people their perceptions of the fairness definitions. But by equalizing those racial groups, that changes the relationship between the group-wise metrics and the overall metrics, because if one group is much larger, then the overall is going to be closer to that group. If you make them equal, then the overall is going to be kind of in between. And then if you're asking people to say whether they prefer the overall most accurate model or this one that's fair, you've changed the relationship between those two. And so that's another confounding effect that may not translate into the real world, because we don't know how complex the reasoning that our participants are doing while they're making these judgments. We have to try to make sure we either study a wide variety of contexts so that we can then tease out and kind of measure that causal effect of that latent concept, or we have to stick to things that we think are realizable or generalizable or realistic to the world so that we can actually translate the results and our findings into real world contexts. And this is, again, we want to make sure that we understand what are the contexts and what are the understandings and what is going on, what's affecting our participants' choices when they tell us what they think and what they prefer. And so the advice here is that we want to use representative contexts and also representative participant samples. Most of these studies use sort of just representative of the United States, kind of broadly balanced, or not balanced, but representative proportional populations. This would be representative if you're doing national policies. But in the United States, very few things are actually implemented at national scale. They're implemented locally or at a state level. So a representative sample for one of these sort of decisions to adopt, for example, a recidivism tool like Compass, that's going to be made by an individual town or city in lots of cases, would need to be kind of varied and matched to those sort of settings. So, or we could even go further and try to understand how does it vary with different populations. But this leads into our last kind of challenge, is that the replicating the results is also going to be a question of sort of the size of the study. So the statistical power of the studies. Psychology has faced this replication study. They learned a lot from the fact that their studies don't replicate, or many of their core results were not replicating. These other effects, these potential spurious causes, factor into this as well, but so does simply underpowered studies. For example, one of the Harrison et al. Study, they made 12 different pairwise comparisons with only 500 subjects assigned variably to the different conditions. And so there's not enough power for that many statistical comparisons and patterns to be detected. So it's important to, and this pattern comes back when we think about validating our study. So we need to have separate groups for validating the tool and then for measuring our findings. And so these questions of power and replication are tied into and compound these other effects that we saw. As we factor out all these different potential spurious causes, we have to bring those considerations in when we're choosing the size of the study that we're trying to do and being able to evaluate that. And so the last design checkpoint or checklist item that we have here is we want to be careful to match the study size to the number of questions. And so that includes both our like explicit questions of interest, like the Harrison et al., the different pairwise comparisons. So I have this many different metrics. I want to compare which people prefer, how many of those there are, but also thinking into any other sort of spurious effects that you're not able to design out that you think you want to test for or compare for or see what's going on, and factoring those in as well. And finally, we want to conclude with that we think this work is important and it's interesting and it's exciting, but as an empirical process that's descriptive, not as a strategy for choosing sort of an optimal definition of fairness. So we're not advocating that you get these better measurements and you can, oh, this is the best one because people preferred it, deploy that automatically, but really that this is a descriptive process. You can learn from people's perceptions and preferences to then factor that into how we should design better systems overall at a systemic level. Thank you.
Thanks for a very interesting talk, Sarah. There's one question from Michael Young, and I think that this will give you an opportunity to expand on this last point that you were making. And so the question is, in your view, what is the significance of fairness preference research? To be more pointed, why might it be important to understand public opinion of ML fairness rather than a more narrow population, for instance, ML practitioners or decision makers?
Thank you. That is a really great question. And first, I want to say that even if we're measuring the preferences of ML practitioners or decision makers, we still need to think of all these factors, because even with our own expertise, we're still humans. We could still be distracted by, oh, this is positive, I'm going to pick that. So I think that one, no matter who we're measuring from, we have to be careful with how we're measuring it and how we're calculating these preferences, like what other incentives or what other things are going on. And then the second part is that I think understanding public opinion of things that affect our public lives and our democracy and all of these kind of big picture questions is really important. Psychologists study how we make decisions and what we prefer anyways. My collaborator, actually most of the other people on the paper are actually social psychologists. So they're interested in studying this, not because they want to build new algorithms, but because they actually study how people are racist and sexist and like how do people express their biased views in other contexts. And so this is a useful context because it's something that's salient. If you pick anybody, their lives are impacted by algorithms today. And so it's a salient case to understand kind of general ways that people express and how those vary. So, something that is certainly of interest is how does it vary if you ask sort of a general population of MTurkers where you have sort of an unknown or maybe even a specifically intentionally like minimally like low education group, how does that compare to lawyers? How does it compare to different groups? And kind of how can we address these things, especially if they're making about policy and regulation? We'll need to know, are people en masse likely to pick something that's going to cause, I mean, they probably are, to cause, harm to a specific group, but kind of understanding how much and when, these are interesting questions from like a research perspective.